Do you know what a protein is? Or where they are? A protein is an organic molecule built up of amino acids joined by peptide bonds. They are found in almost every food. Today we are going to talk about all about proteins, from how they look and work, and what can make them stop working.
Before we talk about them in more depth, it's important to first know more about how proteins are structured and what their purpose is. Simply put, proteins are made up of amino acids, like the train cars that make up a whole train. Proteins can be found in all sorts of places, from our muscles to our organs, and even in a lot of the food that we eat. It's really no wonder why, given how important they are. The main jobs proteins have are providing structural support, acting as biochemical catalysts, hormones, enzymes, and building blocks, as well as initiating cell death when necessary. Proteins have four kinds of structures: primary, secondary, tertiary, and quaternary. The primary structure is the amino acid sequence, and the secondary consists of the local interactions between stretches of a polypeptide chain. A polypeptide is a chain of amino acids joined by peptide bonds. The tertiary structure is the configuration of a protein subunit in a three-dimensional space, and finally, the quaternary structure is the complex 3D structure formed when multiple polypeptides interact and combine. The structure of a protein matters because when something disrupts it, the protein becomes unable to do its job. The process of unfolding a protein is called denaturing, and while in many cases the protein can renature when prompted so long as the primary structure is still intact, it's not doing its job while denatured. I hope this has helped you understand the structure and importance of proteins.
Hey everyone! Today I'm going to demonstrate how to denature a protein. As you may know, denaturing is a process of modifying the molecular structure of a protein. Denaturing involves the breaking of many of the weak linkages or bonds. This changes the structure of the protein, which makes it not work anymore because the structure is immensely important to a protein. So, how do you denature a protein? Well, here I have an egg. Which is made up of a good amount of proteins, about 6 grams of that good protein that makes you so strong. To denature a protein, we need to expose it to a denaturing agent. One of these agents is heat. By heating a protein, you change its shape and make it useless. Here we have heat. As you can see, that is very hot. By heating a protein, you change its shape and make it useless, like I already said. Another great agent could also be pH. Changing the pH drastically would also change the shape. But today, we're going to use heat. Alright, we're going to take this egg, we're going to crack it open, and we're going to put it on the pan. First, I'm going to shoot a little basket here though. Watch this, watch this. Kobe. Alright, take the other egg, crack her open. Solid. And now, Kobe. So now that you have your egg on the pan cooking, you can see it turn white. That's a denaturing. I got some stuff in my hand here. Anyway, like I was saying, white stuff is denaturing. Now, I'm going to scramble my eggs, because I like them just a little scrambled with some of the white part in there, the yolk and the, what's it called, egg white mixed together. Now I'm going to season, because you got to season. That's not important to the denaturing process, but I'm going to season. So now that the egg has denatured, it's actually become useless in a way. It no longer serves its previous function as an egg. And I think you guys know what eggs are. But that's because the protein structures have unfolded. Here we are, we got heat, we got some heat. Oh yeah, look at those eggs, they're looking good, looking real good. But because the heat has unfolded the structure that the protein had, it's now useless and has been denatured. Okay, you guys got that? Denatured. So here I am, I'm just scraping that up. I muted the sound because the scraping was really bad, guys, and I think you all would have hated me for leaving it in. So I thought a lovely voiceover with some jazz music or something in the back sounded a lot better. So here we are, got the heat. Oh yeah, look at those. You ever seen eggs like that? I make some pretty good eggs, guys. If you ever want some eggs, hit me up. I will make you some good eggs. Alright, so these guys have been cooked, and we're gonna see, the heat's off. They're done cooking. So we're gonna take them and we are gonna put them on a plate because I'm hungry. And this is the hard part because I'm doing it with one hand. There we go. I do a decent job at this. So we're just putting them on a plate and I'm gonna eat them. But as you can see, they got really hot. So the protein structure, I spilled one. The protein structure unfolded, and it's useless. I cannot stress that part enough, guys. Protein unfolds and is denatured. So now you know how to denature some protein at home, and a lot of you probably do this like every day at breakfast. So it's a pretty cool little process that happens like every day in your life. So yeah, denaturization of proteins. Try it at home. Peace.
Hey, how's it going? Protein plays a crucial role in the body. Proteins are used to build and repair muscles and bones and make hormones and enzymes. Proteins in general serve as structural support, biochemical catalysts, hormones, enzymes, building blocks, and initiators of cellular death. Cam here consumes about 210 grams of protein a day. Now, Cam eats all this protein because he benches all the time and his muscles break down. The protein in his body goes to the muscles and builds them back up stronger. That's why at only 150 pounds, Cam can bench 220 pounds, which means he's benching 147% of his body. Now, all of that is thanks to him consuming massive amounts of protein, which play a crucial role in the body's natural functions. Without protein, Cam would be crushed by all this weight. Pretty cool how a bit of protein can have such a drastic effect on something.
Take a look inside protein. Is there any structure for me? I won't have to hold my structure because I got protein. Because you only want to hold me when I'm looking primary enough. Did you ever bond me? Would you ever structure us? Every time I fold my structure, well, it's only out of fear that you'll find me primary and one day you'll disappear. Because what's the point in crying? It was never even pep. Did you ever want protein? Was it ever good enough? The protein's got bonds. The protein's got bonds. It doesn't bond right. The peptide bonds are gone. The protein's got bonds. The protein's got bonds. It doesn't bond right. The peptide bonds are gone. Protein structure. Protein structure. Protein structure. Protein structure. Protein structure. Protein structure. Protein structure.
Protein is good enough. Having a codadon. Think about RNA I shouldn't have. So I tell them there's one of me. They making fun of me. Carbohydrate is a bun of me. That bond is a cap. Saying he full but I know he primary. Like, bet he folding those bonds. Think about me cause I know I'm tear sheet.
Damn.
And it's been when it's been. On his phone like Yosemite Pep. Look at my bonds cause you know what I'm on. But when I denature I'm not gonna break bonds. But I don't bond enough without you. And I can't fold enough without you. If we don't fold, does that mean we're through? Don't like denature stuff that you do.
Say it. Say the words. Funny man.
Funny man.
Say the words. Funny man.
Funny man.
No, say the words in the script. Funny man.
Do you know what a protein is? Or where they are?
You see the video?
Yeah, we do. Hey, how's it going? Now, protein plays a crucial role in the body. Protein plays a crucial role.
I can't see. Your face cut off.
Build. I can't do reading. Hormones and enzymes. Proteins in general serve as structural support, biochemical catalysts, hormones, enzymes, building blocks, and God, I can't read that word. Which means he is spending 121% of his body weight. Now, thanks to all of that, you're kicking. Don't. Without proteins, tell me what you crushed by all this weight. Pretty cool about protein. I can't read. I messed up again. It's about 90 grams of protein per day. 190. I totally messed up.
The protein in his body goes to all his muscles and builds them back up stronger. That's why at only, it's because I have to manually.
You understand your protein from 190 to 0. It doesn't matter.
One momento. Alright. Biochemical catalysts, hormones, enzymes, building blocks, and indicators of cell death. Cam here considers